Hey algebra folks. So in today's lesson, we're going to be moving on to our next topic, and we're actually going to be combining what we talked about in terms of just kind of modeling linear equations and fusing it with what we know about quadratic equations, solutions, and also just bringing it back to something that we covered way in the beginning of the academic year when we talked about systems of linear equations. We're actually going to be talking about systems of linear and quadratic equations. So we have two different types of equations going on. So before we get started with this lesson, let's actually just prep our minds for what we're going to cover. And so you have this warm up over here. We're given that we want to substitute this coordinate 0, -3 into both of these equations. And then we just want to write what we notice once we substitute this coordinate into both of these equations. So take a minute, pause the video here, and actually work on this warm-up on your own. And when you're ready to move forward, press play. You ready to check your answer? Let's check it together. So in this question, it's asking us to substitute 0, -3 into these two equations. Now we have these two equations with the same variables here. We actually call that a system. But before we move on to that, let's actually just look at this coordinate. Whenever we're given a coordinate, we want to note that the first value in our coordinate is our x value, and the second is our y. So every time we see an x in our equations, we're going to be substituting in this x value, 0. And every time we see a y, we're going to be substituting in this y value, -3. So let's go ahead and do that. When I substitute in, So when I substitute in -3 for my y, I have -3 equals, and every time I see an x, I'm going to write parentheses and write that x value I'm supposed to substitute in. So this is 0 squared minus 2 times 0 minus 3. I'm going to do the same thing for the second equation. I see a y, so I'm going to substitute in a -3. I'm going to write equals 2. And now I see an x in this equation, so I'm going to substitute in that x value. And remember, whenever I substitute, I write this in parentheses so that my calculator can read it perfectly. So I'm just going to simplify these, right? Let's actually simplify this first equation right over here, right? So my first equation, when I simplify it, I didn't do anything to -3, so I'm just going to keep it there. 0 squared is just 0. Minus 2 times 0 is just going to be 0. And then minus 3. And so that simplifies to -3 is equal to -3. Okay, let's move on to the next equation. I'm going to do that in green. So when I simplify this equation, I have -3, because I didn't do anything to that, is equal to 2 times 0, which is 0, minus 3. And so that simplifies to -3 equals 0 minus 3 is just -3. So when I substitute both of these, when I substitute this coordinate into both of these equations, I notice that, one, I end up with a true equation for both of these, right? Because -3 does in fact equal -3. So I end up with two true equations. So that's my first observation. I have two true equations. And my second observation is that I end up getting the same value in each of my equations. So, in other words, both of my equations evaluate to the same value. Another thing that I notice is that when I look for 0, -3 on this graph over here, when I look for 0, -3, I see that my x is 0, my y is -3, and I actually notice that both of these curves or these lines are actually intersecting at these points. So both equations intersect at 0, -3. So we want to take these three observations into account when we go through this lesson, because we want this to kind of be the backbone of our understanding of solving a system of equations. So for our objective for today, by the end of class today, we can solve systems of linear and quadratic equations by graphing. So we're going to primarily use this method, graphing, for today's lesson. There are other methods, right? And if you remember systems of linear equations, we learned about substitution, elimination. Both of those actually work, but we're going to cover them in later lessons. So I keep mentioning systems of linear equations. Why don't we actually refresh what a system of equation is? So a system of equations is basically a set of at least two equations with two different variables. So when you find a solution to your system, the values of your variables will make all the equations in the system true. So just like how in our warm-up, how when we substituted 0, -3, when we substituted 0, -3 into both of our equations, we ended up with two true equations, and we also evaluated to the same value, right? Another thing that we noticed is that when we looked at this coordinate in our graph, right, it pointed to a specific feature on this graph. It pointed to what we call an intersection, right? And when we have an intersection of these 2 points, that's actually going to reflect a solution or a point at which these two lines are actually crossing or meeting each other. And so if we're thinking about, is there another value that would have a similar effect on our system of creating an intersection, we just want to see where else do we see these two lines intersecting, and we see that they intersect over here as well. So that point is 4, 5. So we're going to say that 4, 5 is another solution. And the reason why we think that is because we notice that our first solution, our coordinate that made both of our equations true, happened at this intersection point 0, -3. So it makes sense that our next intersection point would also be our solution. And so this brings us to our essential understanding. And our essential understanding is that we can solve systems of linear and quadratic equations graphically and algebraically. And this type of system can have two solutions, one solution, or no solution. And we can very easily tell how many solutions our system are going to have based on the number of intersection points. So for example, when we look at this first example over here, we see that our two equations, so our quadratic and our linear equation, touch each other at these 2 points. So we have two intersections, therefore we should have two solutions. Similarly, in this second example over here, we see that this quadratic and linear equation are only touching once, they're only intersecting once, so there's only one point of intersection. Therefore, there should only be one solution. And then finally, when we look at our last example, we see that these two curves never touch. So because they never intersect, there are 0 intersections, we would have no solutions. And so this is really telling us that the number of intersections is directly related to the number of solutions. And so this is really implying that every time we intersect, that's going to be a solution. Intersections are solutions. So let's actually try out an example where we're solving a system by graphing. Now, it's actually going to be pretty useful to have a graphing calculator with you. So we're going to mainly use a table feature of our graphing calculator. So let's say that we were given this system over here where we have this first quadratic equation. So I'm just going to label that as my quadratic. And then over here, this is my linear equation because it follows my y equals mx plus b format. So the first thing that I want to do is just graph my quadratic. So I have y equals x squared minus x minus 2. And we're actually going to switch over to calculator view to actually see how to table this function in your calculator. To graph y equals x squared minus x minus 2, whenever you're trying to graph a non-linear equation, especially use your calculator. And so what we're going to do is just table it. And whenever we create a table, we want to just press our y equals button at the top left over there. And then we want to actually just type in the equation that we have. And so our equation is y equals x squared minus x minus 2. So I'm going to type in the x squared minus x minus 2. So remember, whenever I'm typing in an x, I just press this button next to my alpha button. To square it, I press this x squared button minus x minus 2. And in order to create my table, I want to press second graph. And it shows me this table over here. Now, sometimes it doesn't really start the table at the place where I want it to start. In this case, based on my notes, I want my table to start at -3. It started at -3, but let's say that I want to start at -6. I could just move my up arrow button, or I could just move down until I get to where I want to start. So I want to start at -3, so I just moved my down arrow until my first x value was -3. And so now I'm going to use this table to just copy it down on my notes to help me graph. So now that we've actually learned how to table this function in our calculator, why don't we actually just copy those values down just so that we don't forget them. So when x is -3, in our table it says that y is 10. And then I'm just going to copy the rest of the table. 4, 0, -2, -2, 0. And what I'm actually going to do is just graph these points. So I'm going to start at -3, comma 10. Oh, I don't go all the way up there, so I'm just going to go to the next one. -2, comma 4. So I'm going to place a point there. -1, comma 0. 0, -2, 1, -2, and then 2, comma 0. And I know that because my graph is symmetric, it's going to be over there for when x equals 3. And so what I want to just do now is just actually connect these points. And that's going to be my quadratic graph. I'm going to choose a different color for my linear, just so that I can clearly see these two graphs. And so my linear function is y equals -x plus 2. So I see that my y-intercept is actually going to be whatever this constant is. My constant is 2 over here, so that's going to be the first point that I'm plotting. My slope is going to be whatever my coefficient is for x. I don't see a number here, but I see a negative sign, and so I know that my slope is actually going to be -1. So when I graph this, I'm going to start at +2, and I'm going to go down 1, so down 1 to the right 1, based on what my slope tells me. Same kind of thing if I wanted to draw my next point. I would, once again, from this point that I just drew, from this point that I just drew, I would go down 1 to the right 1. Be right over here. And then what I want to just do now is just actually connect my points. And whenever I'm solving a system by graphing, I just want to make sure that I'm drawing out my lines as long as possible. Okay, so when I look at these two graphs, I see that they're actually intersecting at these 2 points. So right over here and right over here. So let me just highlight those just so that I remember that my intersection points are always just going to be my solutions. So this is telling me that I have 2 solutions, right? And so my 2 solutions are going to be those coordinates of intersection. So my first coordinate of intersection right over here is -2, comma 4. And my next one is going to be right over here on this x-axis, 2, comma 0. And so I just solved the system by graphing. So whenever I'm solving quadratic linear systems, the first thing that I want to do if I'm solving them graphically is just table and graph points so that I have both of my equations actually graphed out. And my second step is just to circle and identify any intersection points. And the reason why I'm looking for intersection points once again is just because intersection points represent solutions to a system. So we have a check for understanding over here. Why don't we pause, where you just work on this on your own, where you're trying to find the solutions to the system where you have one quadratic equation and one linear equation. Take a minute to just pause the video here and work on this on your own. You worked on it on your own. Let's try it together. So the first thing that we want to do is actually just graph this quadratic equation. And let me just label that quadratic just so we're super clear. And this is a linear. Okay. So whenever we're graphing quadratics, we want to make sure that we're being as precise as possible. So this means I actually want to table this function into my graphing calculator to see what kind of points I should actually be graphing on this graph over here. So I'm going to take a minute to just switch over to calculator view. We ended up needing to graph this quadratic equation, y equals 2x squared plus 1. So it's going to be the same process as last time when we were doing our example together. So we need to actually type in this function, so we press y equals. In our y1, you probably had your last example function in there, so you just want to clear it out just to make sure that there are no functions in there that you don't want to table. And then you just want to type this in. So you press 2 to get the x, you press this button, and then x squared plus 1. And then to create your table, remember you press second, graph, and it generates a table for you. So once I've tabled that function in my calculator, I just want to copy it down on paper just so I can more easily reference it. It's not a necessary step, but I like to do that just to be precise. I'm just going to start at -2, just because I know that my y-axis doesn't go up to 19, so I'm not going to include that. So I'm going to do -2, -1, 0, 1, 2. That's good enough. And I'm just going to, once again, copy the y values associated with those x values. So -2, 9, -1, 3, 0, 1, 1, 3, and then 2, 9. And now I just actually want to plot those points and draw my quadratic graph. So at -2, I'm at +9. At -1, I'm at 3. At 0, I'm at 1, 1, 3. I'm bouncing back, and then 2, 9. And then I just want to draw a U shape, a parabola, to connect those two points together to create my quadratic graph. Now for my linear graph, right, I just want to make sure of two things, right? So I want to make sure that I'm identifying my y-intercept. My y-intercept is 5, so I know that I'm just going to start at 5. Now, because my slope is -2, it's this coefficient right over here in front of the x. This is telling me that from +5, I'm just going to have to go down 2 to the right 1. So that should be where my next point is in this linear function. If I want to just, keep going, find out my next point, I know that from the point that I just drew, I would go down 2 again and right 1, and that would be my next point. And now all I want to do is just draw my line as long as possible. Whoops. I want to make sure that I'm drawing a straight line as long as possible. And that would be, whoops. There we go. And so now that I drew my linear equation, I can now identify what my solutions are. So I see that my graph is actually intersecting at 2 points, so I know that I'm going to have 2 solutions. So my 2 solutions are going to be at whatever those intersection points are. I'm just going to highlight those intersection points. So that's my first one, that's my second one, and I just want to list out those coordinates. So for my first one, right, it's going to be 1, 3. So that's my first solution. And my second solution is going to be at this point over here, which is -2, 9. And we have successfully solved the system of equations by graphing. Let's try out another one, just so that we're super clear on this. And so once again, just take a minute to solve the system of equations by graphing. You're going to want to use your calculator for this, so take a minute, solve this on your own. When you're ready to check it, come back. All right, you solved this problem? Let's try it out together. So the first thing that we want to do is just, once again, label so we're super clear. This is our quadratic, and this is our linear. I want to graph my quadratic super precisely, so I'm going to need to put this into my calculator and table it out. And so I'm going to, once again, switch over to calculator view so you can see my exact process when I'm creating my table. You want to graph y equals x squared plus x plus 3. Same kind of process as last time. You want to type this function into your calculator by pressing y equals. You probably have your last function in there. Just clear it out to get rid of it. And then you just want to type in this function. So x to square it, press this x squared button, plus x plus 3. And then to create your table, second graph. Wonderful, you have your table for you. Now that I've created my table in my graphing calculator, I just want to copy those values over again. I'm just going to start at -3. It's, really up to you. I think -3 is a good place for me to start though. -3, -2, -1, 0, 1. All right, that's fine. So this is -3, 9, -2, 5, -1, 3, 0, 3, 1, 5. Okay, so I'm gonna plot those points. So I'm at -3, 9. Oh, oops. 9. And then -2, 5. -1, 3, 0, 3, and then 1, 5. Okay. And I know that I'm going to be at 2, 10 just because it bounces back and it's symmetrical. So something that I notice is a common mistake whenever people are connecting these points, right? If you see that there isn't really like a lowest point, like you just see the same y value repeated, and the x values are consecutive, right? You still have to draw a little dip because whatever's in between these 2 points is going to be your vertex. So it shouldn't just be straight across these 2 points. They should actually dip a little bit lower. And then that's going to be your real parabola. Okay, so we just graphed our quadratic. Let's move on to our linear. So our linear, right, I don't actually see a y-intercept. So if I don't see a y-intercept, my y-intercept is going to be 0. So I know that I'm actually going to start at 0. Now my slope is my coefficient for my x, which I see as -1. So from 0, I'm just going to go down 1 to the right 1, and that should be where my next point in this function is. I'm going to just do that again. From the point that I just drew, I'm going to go down 1 to the right 1 based on my slope and plot my next point. So if I were to just continue drawing this graph, I'm going to draw it as long as possible just so that I'm not missing any solutions. Oh dear God, that's not straight at all. My apologies. Okay. And if I keep drawing this graph, I actually notice that they never intersect, right? And so because these two systems never intersect, I know that there are going to be no solutions. No solutions. Because do not intersect. Real bummer. Okay? So we actually just finished our main skill for today. We did learn how to solve systems of linear and quadratic equations graphically. And so our next lesson, we're actually going to learn how to solve it algebraically using those same methods that we actually covered when we learned about systems of equations in the beginning of the year. In addition, we're actually going to start drawing those connections between what we learned back then about solving systems and what we're learning about now, solving systems that are a little bit more complicated because they involve quadratic equations. So for your homework today, you just want to work on problems 1 through 7. And if you have any questions, make sure that you talk to me, call me, email me, and good luck.